Hello everyone, welcome back to Educational Era. Today we'll explore some terms related to simple harmonic motion such as amplitude, time period, frequency and phase. So first we will take an example of simple pendulum again and let's explore these terms. So here is our simple pendulum right here, and let's say after certain time when we move the simple pendulum up till here, starts oscillating from here to here and again repeat the same movement again and again. So what is amplitude? So amplitude is the maximum distance that a simple pendulum travels from its mean position. So for example, let's say, right, we have, so this is our mean position, and let's say that we pull this simple pendulum up till here, and if we let it go, then the maximum distance that it can travel is from here to here, right, up till here only. It won't go any further than this. So this is going to be our amplitude right here. Amplitude is generally denoted by A, right? So keep that in mind. So this is our amplitude. Now what is time period? So time period is going to be the time that a simple pendulum takes to complete one oscillation. So what that basically means is, if we pull the simple pendulum till here and we let it go, then how long would it take to move from here to here and again up till here, return back to this position? Well, basically that is what time period is. So the time taken by a simple pendulum to complete one oscillation is time period. And now frequency. Well, frequency is going to be the number of oscillations that a simple pendulum can cover in 1 second. So it is basically denoted by 1 over t, or hertz, right, or per second. And this basically means how many oscillations it can cover per second, right? So per second. So keep that in mind. Now phase. Well, for phase we need to make a different diagram. Let's say this is our pendulum, right? This is our pendulum right here. Let's say we pull the pendulum up till here. Now let's say after certain time the pendulum gets up to back, this pendulum oscillates up till here. So let me draw this real quick. Oops. All right, fine, whatever. So this is our pendulum here. So we know that displacement is r sine omega t, and this omega t right here is our phase. Let me use different color. This right here is our phase, and we know that omega t is going to be the angle. So omega t is this right here. So phase is basically a physical quantity, right, an angle that determines the position and direction of this pendulum. So if we were to uh, plot the motion of simple pendulum in the graph, right, so let's say at the time, so this is our omega t and this is our y. Let me use a different color. Is that right? And we know that at first the pendulum is at rest, right? So from here it moves up till maximum displacement, that is our amplitude, right, and it just moves like this continuously, right? So this is our pendulum right here. Now if you see, at a certain time, at this time right here, our phase is going to be 0, right? And this time right here, our omega t is going to be, our phase is going to be pi by 2 or 90 degree. and this is our 0. So what is phase giving us? So phase is giving us the time, phase is giving us the position of and the direction of simple pendulum. So if you see right here, our displacement is negative, right? So it means that our simple pendulum at this point right here is somewhere about the opposite direction from here, right? So let's say it is right here, and the negative amplitude indicates the maximum displacement it travels in here, right? This, so the phase is basically giving us the direction, whether it is located at the right of our mean position or the left of our mean position, and it is giving us the displacement it is traveling per per time, right? Per omega t, per unit time. So let me write down the definition of all these four quantities, and you'll know a little bit better. Alright, here is the definition. And amplitude is the maximum displacement. Time period is the time taken to complete one oscillation. Amplitude is generated by A. Time period is generated by T. Frequency is generated by F. This is equal to 1 over time period. And our phase is the physical quantity which gives the information about the direction and the displacement. Direction and the displacement of a body is generated by omega t. Well, that is all for today, and in our next video we'll be discussing on the energy associated with our body in simple harmonic motion. So thank you so much for watching. Make sure to like and subscribe.